Hi guys, welcome back to Program with Sam, and today it's Java Lesson 2. So last time we saw that Java has primitives, and as a result you technically could make the argument that Java isn't an object-oriented language because of the existence of these primitives. Fortunately, Java does actually have objects for all of those primitives. So I have over here the primitives that we had last time. They're exactly the same, and underneath them I've also given the actual object version as well. So for every primitive, like byte, there is a byte. And that's obviously an object, so it's a class, so it has a capital letter, as we discussed in a naming system last time. And it's usually the full word. So for char, which obviously we know is abbreviated for character, they just use character. And these objects then give you advanced functionality. So for instance, whereas before, if we did p.exampleByte, there's not really a whole lot of functions that come with it. It's mostly just sort of like, you know, bog standard stuff. It's realistically, it's making more, it's just going to add more code for you. So for example, if we hit return, it's just going to return the example byte. It's not actually calling any functions. Whereas if we do p.byte, byte object, isn't it? Byte object, we then have access to a huge range of functions. I say huge range, it's not that many, but it's definitely more than the primitive data type. These are all things that you can sort of just, you know, mess around with yourself in your own time. But one of the most important ones is toString. And that is a function that comes with majority of classes that come with Java by default, and it's good practice when you create classes to write yourself a toString function. And that's then exceptionally useful for debugging or for just outputting things to the user. So yeah, that's really for you to just have a play with. It's just something that I thought I'd bring up because obviously we covered primitives last time. Realistically, you're probably still going to use primitives just because it's what a lot of people are used to. But I've started switching over to using the objects more and more simply because you do have more functionality. And so with that, we're going to move on to some more useful objects in Java. Strings are one of the most useful classes in Java, and Java is actually quite a powerful language for string manipulation. We'll see why in a minute, but there are a multitude of functions that you can use with a string to essentially manipulate it, cut it short, take a substring, take just a single character. Lots and lots of different things you can do with strings. So to declare a string, what we need to do is we need to do a string, and we'll call it example string, and we can set it to anything we want to. Hello world is probably the classic example, isn't it? Hello world. Right, hello world. There we go. So we have a string, hello world. If we just do is to create a string tutorial object, t tutorial is equal to new string tutorial. There we go. So now we have access to the string, example string. Let's have a look at some of the functions we got. We got substring, and that'll allow you to clip a part of the string off. Either between two given indices, which is the second one down there, or just from a given index. You can check what it ends with. Now, why might that be useful? For if you want to check a file extension. So we can do ends with that. Now that's a Boolean statement, so probably what we want to do is, we can't toString it. Let's just do system.out print line. That should work. Yes. So then if we run that, it should just say true, I think. Yeah, because it ends with an exclamation mark. If we do anything else, it should come up with false. Yes. What other sort of useful functions can we think of? Example string dot, what have they got? Matches. So matches is a very useful function. You can use it to either pattern match exactly with something, or you can use regular expressions to do pattern matching. Now, why might that be useful? That might be useful when you're doing pre-processing of data. Let's say you want to make sure that an attribute of data all matches the same syntax, and if it doesn't, it's an erroneous value, and you want to get rid of it. So Another one is equals. Now this is important. Equals is a very important function because it allows you to check whether an object is an exact match with something. If you tried to do this, if you tried to do equals equals in a conditional statement, it may not behave the way you expect. So equals is the way to check whether two objects are the same. And obviously you've got equals ignores case, content equals. There are a multitude of functions available to you. And you just really have to sort of encounter when you need something, and that's when you find the function. So there are a lot of things you can do with strings, and strings are obviously essentially natural language. They're what you would be typing, what you do in your word processing. So it's important to have string manipulation in the back end of your program. So I would highly recommend sort of just playing around with them, seeing which functions might be more useful to you. You don't have to memorize all of them. Obviously, there are a lot. But essentially with Java, what you'll find is that if you need to do something, someone will have already done it, or there'll already be a function for it. And that, I feel, is the best way to learn. So what I'll do is I'll do some of the more commonly used ones in this main function and put that on GitHub for you to have a play around with. But yeah, realistically, playing around with strings is just something that you'd have to do yourself. Splitting strings, concatenating strings, and substrings are very important. Okay, so I've done a couple little bits in the function that we're just going to nip through now. So here I've declared several strings, hello world, exclamation point, and a string for space. And to demonstrate how concatenation works, I've done string concatenate is equal to hello plus space plus world plus exclamation point. And then we print out concatenate. So what that should give us is essentially just hello world. So if we play that, we should then see at the top, hello world. So next I'm demonstrating substring. So this says welcome to program with Sam. And this is the substring with just one index. So what that means is it will take the substring any point after that index, including that index as well. So P is on index 11. So it should then take all the rest of it. Now, the difference between that and the one with the 2 index is it then takes a finite window. So it takes between 11 and 18. So we get program. And we printed them out. And you can see that down here in the bottom. Program and program with Sam. Now, here is where I sort of experiment with the replacing. So what we have is we have the cat sat on the mat. And what we want to do is replace the word cat with the word dog. So we use the .replace function on the string, targeting the word cat with the replacement word of dog. And as you can see down here, it successfully replaces that. The next thing I wanted to show off was regular expression, so pattern matching. And what I've done is I've essentially said that we're comparing these 4 strings to check whether they match the pattern of essentially 3 capital letters. So A is 3 capital letters. So it should match this pattern, which it does. B is D, lowercase e, and capital F, so it doesn't match this pattern of 3 capital letters, and it says false. C is GHI with 2 lowercase, so it doesn't match the pattern, so again it's false. And then the last one is JK and L, all uppercase, so it does match the pattern of any capital letter 3 times, so it's true. Next, we're going over equals, so showing how strings equal each other, and this is then used for objects in general, not just strings. But we've declared the strings hello world, not hello world, and then we've declared one that's equal to hello world. So Z is equal to X, so we know that they're exactly the same. The first time we're comparing X to Y. So does hello world equal not hello world? Of course the answer is false. It's not hello world, obviously. Then we're comparing X to Z, and we know for a fact they're identical, so it should come up as true, which it does. So the last one I've sort of gone for is just getting the length of a string. So the length of a string is done sort of like in the number of characters that there are there. So I've declared the string experiment, and I said the cat sat on the car, mixing it up a bit, I know. And then we're just going to print out the length, and in this case it's 22 characters. So that's just an example of some of the things you can do with strings. I think for a lot of people it's probably sort of like Quite interesting to see that you can do substring, that you can replace just specific parts that you want. Eventually, we'll probably demonstrate string splitting, but we'll do that after we've sort of gone over array lists, I think, and arrays. So we'll do that later on in the video. Okay, so we've got our array list demo set up. There's a couple of things that I want to cover here. Just some of the sort of like the bog standard functions that come with array lists. Now, what are the benefits of using array lists over arrays? Well, with arrays, you have to initialize for a set number of values. So if I was to declare an array like string, or let's do int array like this is equal to new int, and then I'd have to specify the number inside here to specify how many elements I want. And then when you get to a point where you want to add more elements, that can become more challenging. Not impossible, but more challenging. Array lists are essentially dynamically resizable lists. So what we have is the ability to declare an empty list and then add to it as much as we like, and remove from it as much as we like. And all of the memory like management and allocation is taken care of for us by the Java virtual machine. Now, like there are many similar constructs in other languages. Like I think vectors in C++ are very similar to this. Array lists, obviously, in C# are very similar. Python is in a whole league of its own. So here I've declared an array list string, and I've called it string list. And you've just set it to a new array list because obviously it's an object, so we have to instantiate it. There we go. We've made a new array list, and we've called it string list. Then I add 3 strings. I had hello, I add a space, and then I add world. Then there's the function to get the length of the array list. So this is size in array lists. So when you want to find the length of your array list, it's size is the function name, which you know, seems a bit counterintuitive, but you know, it all means the same thing, really, doesn't it? So we then output the length. We get the element at a specific index. So in this case, we're going to get the index 2, so that should be world. And so instead of indexing like in an array, you would have string, or like you'd string list, and then you'd like index at 2. Instead of doing that, you do get, and that's how you access the individual elements of your array list. And now obviously you could replace that with an index for a for loop and iterate over that. But we'll see in a minute that for loops are done a bit differently when it comes to array lists, because they're counted as a collection. And we can use the special for each loop that I've talked about before to iterate through an array list. They also have a toString function, which just prints out the contents of the array list, comma delimited. You can set an object at a given element. So in this instance, we're going to do the set at index 0, which is hello, to goodbye. So it's just changing the string from hello world to goodbye world. We also have contains, and this will return true or false depending on if at any point in the list that word appears, and it's exactly like that. So if we remove the exclamation mark, it wouldn't work. But if there is a string in this list that matches that, boom, it will return true, which we know there should be because world is there. Then iterating over the list. So this is the for each loop that I just mentioned. Essentially, you can declare the object type that's inside the list. So in this instance, we have strings inside, but realistically, that could be any object. And we then just declare the dummy. It's the same as doing an int I, but you've just done object, and in this case x, and then you do this bit. And what that is essentially saying is for every string x inside the string list, we want to iterate through it, and we're just going to output it. Note that we're not doing print line. We're just doing print, so it will all print the same line. That's another difference, and then we just add a new line at the end. So then we're going to just demonstrate testing, returning an array and returning an array list to just further highlight sort of like the benefits of potentially using array lists over arrays. Realistically, it's obviously going to be application dependent. I personally only use ArrayLists now, but I'm sure people still use arrays, and there are probably good reasons for doing so. So the functions are defined up here, so we just declare a new list, and then we just add some items and return it, and we do the same items in an array and return it, and we just see what we get as the output. So when we run it, we get the length is 3, which we know is right because it's 1, 2, 3, length of 3. The string at the index of 2, which is 0, 1, 2, world, and it comes up with world. The toString function outputs hello, and then the space, and then world, comma separated, obviously. Works out well. Setting the object at a given element. So we don't necessarily see that straight away, but we know that it's happened because later on when we output it, in the for each loop, it correctly outputs goodbye world. So we know we've correctly updated at index 0, hello has now become goodbye. Checking if it contains world is true, because obviously we just discussed that it does contain world. We've just seen the for each loop output the entire sentence. And then the returning of an array has obviously returned this. Now that's very interesting. It's done a capital L for some reason, unsure why, but it's returned this java.lang.string, and then I assume, to be honest, that looks like a memory location to me in the Java virtual machine. Whereas when we return the array list, that is what they've returned, which is the array list. And so that's sort of like a subtle difference, is that array lists are objects, so they'll behave in the way you expect them to in functions, whereas when you're returning an array, clearly that's not what we wanted. It's just not the output. It's returned what appears to be a memory address, and we're not, I mean, we may be interested in that, but I'm guessing we're not interested in that. So that's really sort of like some of the more useful things you can do with array lists in Java. And what we're going to do now is we're going to sort of take a look at file handling and sort of how to read in from a file and out to a file. So I'll see you in a bit. Okay, so up next is file handling. Now, up until this point, all of the variables and stuff that we've been using would only be accessible to you at your program's runtime. But what if you want to save some particular states or some particular variables that you can then load in future, runs of the application? And this is where sort of like file reading and writing comes in. This is where it comes in handy to be able to save some settings that you have, perhaps in your application, or perhaps just save perhaps a user's saved data. Perhaps they're working on something like a text file that you want them to save. And that's where this kind of comes in handy, this idea of storing the files to the disk and then loading them later. Now, for the purposes of this tutorial, I'm just going to go over reading and writing to text files. And that's very simple to do in Java. There's things called a file reader and a buffered reader and a file writer and a buffered writer. And that just lets you write pretty safely to a file a string, essentially. So what I've done here is I've made two functions. The read file function, which starts by declaring an empty string, and then we try and do this. Now, the reason there's a try and catch exception is because we're doing file input and output. And what that means is that if we encounter an error, such as maybe the file doesn't exist, the exception will get caught here. And it just won't execute like the majority of this code. It's a way of sort of, it's dealing with errors in your application. And we may get onto that later on in the course. But for now, just trust me here. We're going to try and open the file of the given file name. We're going to then open the file reader using the file and the buffered reader using that reader. And then we're going to create a dummy variable called line, which is then going to be used to read in the lines from the file. So we're going to read in line at a time. And whilst that line is not null, we're going to append it to the read string that we declared earlier. Then after all of the lines are done, we're going to close the readers and return that variable. Now on the flip side, we've got a write file function. And this one just starts with the try. We create the file with the file name, the writer with the file, the buffered writer with the file writer, and then we just write the string that's been passed. Then we flush and close, and that's it. It's quite simple. So what I'm going to demonstrate here is essentially we have a string sentence. This is my sentence, and we're going to try writing that to the file test files writeout.txt. And then we're going to try reading it in with the read file function, and then we're just going to print it out to the console. So if we try running that, you see we've now got a file in the File Explorer window, writeout.txt, which has this is my sentence in it. And then in the console as well, you'll see we have this is my sentence. So what you can do with your settings or some variables that you want to save, you could just store them in a comma-separated list and then read them in, use the string split function to split them on the comma, and then you have a list of variables all ready and waiting for you to then use in your application. So that's another thing that you can sort of consider and play around with. Okay, so the last bit we have to cover today is the scanner. And this is sort of like a useful tool for you to be able to get input and output response to and from the user through the console. Is what we're going to be doing. So this is going to be useful for your sort of like early stage applications, because by this point you know how to make variables, you know how to do conditionals and loops. So by this point you're getting ready to make something that you can actually interact with, something where you can give it some values and then modify those values in your application and then return something. So for instance, perhaps a calculator would be a good project to do. Like you give it two numbers and it adds them together, or you give it two numbers, it times them together. Or you could input string and it would split it and then figure out what it's supposed to do from there. You can take it as advanced or as simple as you like, just have fun and play around with it. But what we've got here is we're declaring a scanner object called scanner, and we're using system.in, which is obviously through the console. Then we're going to system.out, enter your name. So we're asking for your name, and at which point you're going to enter your name using the scanner.nextLine, and it will store it in the string name. Then we're just going to output a response, which is hello name, pleased to meet you. So if we give this a cheeky run and we have a little look, it now says enter your name. So I'm going to go Sam, enter, hello Sam, pleased to meet you. So that's probably going to about cover it for now. Next time, we're going to be looking at creating your own classes. So we'll be introducing constructors. We'll be talking a bit about the garbage collector in Java. We'll be discussing some of the pitfalls that occur with access modifiers. And we'll be talking about then getters and setters and how we go about implementing them. If you'd like to follow the Twitter at ProgramSamBlog, or just follow the blog directly at programwithsam.co.blog, that would be much appreciated. And I'll see you in the next one.